Good day everyone, we're going to take a look at exercise 8 from chapter 8.1, which is still about volumes of prisms. Before you're going to do this exercise, remember sometimes in this chapter you can get questions which have a lot of, how I call it, flavor text. Some kind of introduction to a practical problem. And a lot of it is just you being introduced to the practical example. But remember to scan for information that is actually useful for calculations. For example, here this is about irrigation channels, okay, yada yada. But they do say, in the end, the side channel is 500 meters long. That's something that we do have to use in our calculation. Because they ask us how many liters of water can be in the side channel. If you're going to take a look, they give you this sketch here, right? You can see that this is going to be the base. Why? Well, this is not a rectangle. All the other forms are rectangles, and in the end I have the base, or you could say the top face, that has the same form. So I have to calculate the area of this form right here. How can I do that? Well, there is a quick way and a bit of a harder way. Some of you might say, well, I'm going to calculate the area of this rectangle and then subtract the two triangles that are right here. That's absolutely fine. But I see that this is a trapezium, and a trapezium has this formula, right? Half times a plus b times height. And then a plus b were the two parallel sides, so I can do 25 plus 45. And the height is given, that's 20. And I think this is a bit quicker. If you want to use the other method, feel free to do so, right? If I'm going to calculate this, it's going to be the same as 35 times 20. It's going to be 700. 700 what? I'm talking about centimeters, right? So this is squared centimeters because I'm talking about area. How many liters of water can the side channel contain? Well, that is going to be the volume of this prism. That is the area of the base, 700, times the length of the, or you could see the height of the prism. Well, then we have to watch out because this is in centimeters and this is in meters, right? So if I'm going to now convert this to centimeters, I would get 5,000 decimeters, so I get 50,000. If I'm going to calculate this, your answer is going to be in cubic centimeters. Let's see, how many zeros do I have? 1, 2, 3, 4, 5, 6. Right? And I don't want my answer to be in cubic centimeters. I want it to be in liters. So I now have to convert this to cubic decimeters, and I have to divide by 1,000, and that is the same as liters, right? So the answer is going to be 35,000 liters. Okay, that's the answer for B. For A, sorry. For B, they state that Mr. Gonzalez needs 25,000 liters of water per day. When he opens the channel, the water flows into this field at a speed of 2 meters per second. How many minutes per day will Mr. Gonzalez open the channel? Okay, let's take a look. That means that I actually have a prism. Per second, what is the volume of water that will go out? Yeah, that is still the volume of the channel per second is going to be area of the base, that's still 700, but not times 500 meters, but now times 2 meters, so times 200. Gives me 140,000 cubic centimeters. And I wanted to convert to liters again, so I'm going to say that it's going to be 140 liters. That's going to be 140 liters per second, right? Because that's what happens when I open this channel up. In 1 second, this will flow through. How many minutes per day will he open the channel? Well, this is per second, so 140 liters per second. That means that I need 140 times 60, and then it's the part where I take out my calculator. That's going to be 8,400 liter per minute. And I need 25,000 liters per minute. So if I now divide this is what he needs, 25,000 liters. I have 88,400 liters per minute. This will approximately give me 3, right? If you're going to calculate this exactly, the answer is, let me punch it to my calculator. I can say like this, it's about 2.98 minutes. But they ask how many minutes per day will they open the channel. So I will just say, I'm going to round it to whole minutes. I will say 3 minutes per day. Okay? So the difficulty here lies in the fact that you have to now visualize that 2 meters per second means that every second you have a prism with a certain volume that is being released with a volume of 140 liters per second. And we need to fill 25,000 liters, and they want the answer in minutes. That's why I'm going to re-evaluate this as not per second but per minute. Divide what you need by how many minutes, of how many liters you get per minute, and then you get how many minutes you need per day. Okay, I think this is maybe the most difficult exercise of this paragraph. I think 9 after this is also tricky, but not as tricky as this one. This one needs a bit more visualization than 9. We're all used to Toblerones, right? Not so much for irrigation channels. Good luck!